In this lesson, we're going to be talking all about Ferris wheels. So you see a Ferris wheel below. It's called the Sky Wheel. And there is some important information here on the right side that I want to go over. The first thing is that it tells you the diameter of the wheel is 88 feet. So what that means is if you started at point B and you went all the way down through the center and you ended at point D, that red distance is 88 feet. And that is labeled over here on the right side of what looks like point A. Now I want to point something out. The diameter is from B to D, but if I wanted to look at just the radius of this Ferris wheel, I would take this 88 and divide it by 2. So each of these halves of the diameter, which are the radii of this Ferris wheel, would be 44 feet. The next thing it tells you is that the highest point on the wheel is 100 feet off the ground. So the highest point on the wheel is point B, so that's this one right here. And it's telling you that it's 100 feet off the ground, and that's what this measurement here on the way right side is telling you. The lowest point on the Ferris wheel is point D. Now in order to figure out how high off the ground it is, that would be this distance here, from the bottom of the wheel to the ground. The ground is down here. To figure out this distance, we would take the total height, so that would be 100 feet, and we would subtract the distance of the Ferris wheel, and that would leave us just with this height right here. So if I take 100 and I subtract 88, it gives me 12. So that tells me that the distance from the ground to the Ferris wheel is 12 feet up. So that's telling you that point D is actually 12 feet off the ground. The last piece of information isn't really anything that we need to label, but it's telling me that the wheel completes one rotation every 60 seconds. So what that means is if you started here on point A and you went all the way around the Ferris wheel, it would take you exactly 60 seconds to do that. All right, so we've got our Ferris wheel picture kind of off to the right. I want to add in a few labels that we did on the previous slide. So remember that this is 12 feet off the ground. We also figured out that the diameter is 88 feet, but that means that the radius in each direction is 44 feet. All right, so now question 1 is saying, what is the height of the car at each of these points? So at point A, we're right here. This is point A. I'm going to use a different color. At point A, we are actually 56 feet above the ground. And the reason it's 56 is because you're taking this 44 right here, but then you're also adding this 12 that gets you back to the ground. So it's 44 from A to the bottom of the Ferris wheel, but then it's 12 from the bottom of the Ferris wheel to the ground. So this is actually a total of 56, and I got that by doing 44 plus 12. All right, now point B is not so bad because they actually tell us that's the highest point on the Ferris wheel, and it says that that is 100 feet above the ground. So that one is pretty much given to us. Now back down to point C, which is over here. Point C is level with point A, so that's going to be the same distance. That's 56 feet. And then point D is all the way at the bottom. That was the lowest point on the Ferris wheel, and we figured out on the previous slide that that point is 12 feet above the ground. Now the next thing, question 2, it says fill in the table for the height of the car if it starts at point A and rotates counterclockwise. So we're starting here at point A, where I'm circling in green, and we're going counterclockwise. Now you'll notice that the time increments are going by 15 seconds. If I know that this Ferris wheel goes around one rotation in 60 seconds, and I'm going in 15-second increments. That means that I'm doing 4 increments every rotation. If I take 60 and I divide it by 4, that's what those 15 seconds are. So every time that I move from A to B, B to C, C to D, it's a 15-second increment. So at time 0, I'm starting at A, and we talked about how A, right here, is 56 feet above the ground. In 15 seconds, I will now be at point B, and we looked up here that B is 100 feet off the ground. In 30 seconds, I will be at point C. So let me actually label this. So this is 0 seconds, B was 15 seconds, C is 30 seconds. So after 30 seconds, I would be at 56 feet. After 45 seconds, I'm going to be down at point D, which is 12 feet off the ground. And then at 60 seconds, I'm going to be back at A. So that would be back to 56. Now 75 seconds is basically saying 60 seconds, which is all the way around, plus 15 more. So now I'm basically repeating myself. So instead of, now I was at A, 15 seconds more is now at point B. So that would be 100. 15 seconds more than that is now at point C, which is back to 56. 105 seconds is 15 seconds more than that, so we're down to 12. And then finally 120 seconds would be the same as 2 minutes. So that's 2 full rotations, so you're back at A. All right, now the next question, is this function periodic? The answer is yes, and the reason is because if you look at your y values, they're repeating themselves. It's the same y values over and over again. Even as the x values go up, the y values are just kind of doing the same thing over and over again. So I'm going to say the answer is yes, and the reason is because the y values, which are representing height in our scenario, repeat. And they do so in a predictable pattern. Now we're going to plot those points that we just found on that table. And what this is going to do is it's going to reveal a graph, and I think it's going to look familiar once you see it. So the first point that was on our table from the previous slide was 0, 56. So I'm going to go, when x is 0, 56 would be right about here. Okay, and then my next point was 15, 100. So at 15, I'm going up to 100, which is about here. At 30, we were back to 56. At 45, we were all the way down to 12. That was the lowest point on the Ferris wheel. And then at 60, that was the 1 full rotation. We were back to 56. And then we're going to repeat those values again. So now we're up to 75, which is at 100. 90 is back to 56. 105 is down to 12. And then the completion of our second rotation is at 120, 56. And now if I connect these dots, and I'm going to do it with a curve, I'm not going to do a straight line. This should look pretty familiar. So the next slide is going to ask us several questions, and I want to go over it now so that you can have a visual of the graph. The first thing it's going to ask us is what the midline is. There are 2 ways you could figure out the midline. Some of you will be able to just look at it and see that the midline is at 56. So I'm going to go ahead and draw that in, and then I'll show you how you could do that algebraically. So here's my midline at y equals 56. If you have trouble just looking at the graph or you don't trust yourself, you could use this little formula. So to figure out the midline, you take your top y value plus your bottom y value, and you divide by 2. So the top y value is up here at 100, and your bottom y value is down here at 12. So if I did 100 plus 12 over 2, that's 112 over 2, and if you divide that, it gives you 56. So this would be your midline. The next question it's going to ask is, what is the amplitude of the graph? So again, if you can look at the graph and see what it is, that's fantastic. What you're looking for is the distance from the top point, the maximum, down to the midline, and then from the midline down to the minimum. The answer here is actually 44. And the way that you can figure that out is by, there are a couple different ways. The way that we showed you was to take, for your amplitude, was basically the same formula as midline, but now you're subtracting. So you would do the top value minus the bottom value, and then divide by 2. So the top value is 100, the bottom value is 12, which gives you 88 over 2, or 44. So the amplitude, meaning from the midline to the maximum and from the midline to the minimum, is 44. It's also going to ask us what the period of the graph is. Remember that the period is the length that it takes to complete one cycle of the graph. So I'm going to start here, and I'm going to highlight one cycle of the graph. So one cycle ends right here on this big blue dot, and if you look down to the x-axis, it tells us that the period of this graph would be 60. And if you think about it, it kind of makes sense because it told us at the beginning that one rotation of the graph, so one full cycle, takes 60 seconds. So it makes sense that the period would be 60. Now the last thing I want to mention before we move on to the next slide is whether this is more of a sine graph or a cosine graph, because they are very similar. And this graph actually represents a sine graph. And there's a couple ways that you can tell. The first thing I always look at is where x equals 0, which is right here. Is your graph starting on your midline or is it starting above your midline? And this one right here starts on the midline. So that's your first clue. If you look at the part that I highlighted in light blue, you can see that it represents a hill and then a valley. If you remember that the cosine graph looks more like this, where it's kind of a U. And that's not what our graph looks like. So this one is going to be a sine graph. And that's going to be important to us later because we're going to have to be writing the equation of this graph. We talked a lot about these things in the previous slide. So I'm going to go through and just fill them out. We discovered that the midline was y equals 56. The amplitude of the graph was 44. And the period of the graph was 60 seconds. From here, question 8 asks us to find the value of b. Remember that period and b are not equal to each other. They are related to each other, but they're not the same. So in order to figure out our b value, we're going to have to use our little formula that if you take 2 pi and divide it by the period, it will give you your b value. So I'm going to take 2 pi and divide it by 60, which is the period. And if you reduce it, you get pi over 30. So this is our b value. This looks a little backwards because you're used to seeing your b value be kind of a regular number, and then the period is the one that has pi in it. It happens to be backwards in this problem, and that's okay. It doesn't make it wrong. It just kind of looks strange to us. So the next thing I want to do is write the equation of this graph. Now, we talked in the previous slide about how our graph represents a sine function and not a cosine function. So we have to make sure we put in sine instead of cosine when we write this out. Amplitude goes first, so I have 44, and then I have sine bx. So my b value is 30, and then I'll put in, pi over 30, and then I'll put in the x. And then the last thing we write is our midline number, which is positive 56. Question 10 asks us to use our calculator to find f of 20. So I have over here, where I'm going to put this orange star, that's how you should type it into your calculator, but there's one catch, and that is that your calculator needs to be in radian mode. If your calculator is not in radian mode, you're going to get the wrong answer. So what this is telling you is that if you plug in if you plug in 20 for your x, which is this 20 right here, it's going to give you 94.1. So that's f of 20. And what that represents is if you go onto your graph from the previous slide and you see where x is 20, and then you go up to the graph and you see what the y value is, it should be about 94.1. So what it represents is the height of the wheel after 20 seconds. So it's the height of, and I'm talking specifically about the car where you started. So the height of the car after 20 seconds. So you could actually figure out the height of that car after any amount of time. All you would have to do is plug that in seconds into your x value, and it would tell you what your y value is at any particular time. Now we're going to compare the sky wheel to two of the Ferris wheels below. And these are given to us in different ways. So we kind of had everything about sky wheel. We had a diagram, we had a table, we had a graph, we had an equation. Now when we're talking about round robin, all we have to look at is a table. And when we're talking about the spin cycle, all we have to look at is an equation. So if you refer back to the previous slides, we're talking just about period for all of these Ferris wheels. If you refer back to those slides, you will see that the period of the sky wheel was 60 seconds. And that's how long it took for one full cycle, for one full rotation of that Ferris wheel. Now to talk about the round robin, what we're looking for here is how long does it take until the y values start to repeat themselves. So if you look here, our initial y value is 8. And if you look along your y values, the next time it gets back to 8 is right here. So what that tells me is that the period of this graph is 48 seconds. And then for the spin cycle, to find the period of that, we have to use that 2 pi over b formula. So I'm given my b value is pi over 45, but to find the period, I have to do 2 pi over b, which is pi over 45. So since I have a fraction and a fraction, I'm going to multiply by the reciprocal of pi over 45. My pi's will cancel each other, and then 2 times 45 is 90. So the spin cycle, the period of the spin cycle is 90 seconds. And then down here, it asked me which one rotates faster. So the fastest one would rotate in the least amount of time. So that means that the round robin would win as the fastest Ferris wheel. Question 12 asks us to find the maximum height of all of the Ferris wheels. We already know that the maximum height of the Sky Wheel is 100 feet. We were told that basically the very first thing when we looked at that diagram. Now we have to look at the round robin and the spin cycle. The round robin is actually pretty easy to figure out. If you look at your Y values, so if you look at this bottom row of values, whichever one is the highest is your maximum height. So 82 is our maximum height for round robin. The spin cycle is a little bit more tricky because all we're given is the equation. So it's hard to describe without the picture, but I'm going to try. So our graph looks something like this, where we had our midline, and that was at 56. And then the graph looked like this. And our highest value was 100, our lowest value, which it doesn't look like it, was 12. So what I want to, and one other thing I want to mention on here is that our amplitude was 44. So in order to find the maximum value, kind of a cheat or a little formula that you can use is if you take the midline, which in the Sky Wheel was 56, and you add the amplitude, that's going to always add up to your maximum value. So if I did 56 plus 44, that's going to give me 100, which is my maximum value. And that will always work. So I'm going to write that down under this hint, is if you take the midline and you add the amplitude, that's always going to give you your maximum height on your graph. So let's take a look here for the spin cycle. I can see that my midline is 43 and my amplitude is 33. So if I add those two things together, 43 plus 33, that gives me 76. So that would be my maximum height for the spin cycle. Now it asks us which one is the tallest. So we're looking for the largest number. So of these three values, the Sky Wheel is the tallest because 100 is the largest number. Now the last question is asking us to find the diameter of all three Ferris wheels. Again, we know the answer for Sky Wheel. We were told that at the very beginning that it's 88 feet. For the spin cycle, I'm going to skip to that one. There's a little bit of a trick, and that is that if you take whatever your amplitude is, because remember that the amplitude for the Sky Wheel was 44. If I take that and I double it, that's going to give me my diameter. So that's our little trick here. So I know that the amplitude for the spin cycle is 33. So if I do 33 times 2, that gives me 66. So that is the diameter of the spin cycle. Now for the round robin, we're going to use that same trick, but it's a little bit more work because we can't see what the amplitude is just by looking at it. So what we're going to do is we're going to use that little formula that we used a few slides back, which is to find the amplitude. If I take the top value minus the bottom value and divide by 2, I'll get my amplitude. So I'm looking now at this chart right here. My top, which is my max, is right here. It's 82. And then my bottom is my lowest value, which is 8. So I'm going to do 82 minus 8 over 2, which is 74 over 2, or 37. So the amplitude for the round robin is 37. So now if I take my 37 and I multiply it by 2, I end up with 74. So that is the diameter. Now you might be thinking to yourself, it seemed kind of unnecessary that we took 82 minus 8, which was 74, which was the answer, and we divided it by 2 and then immediately multiplied it by 2. Why did we do that? And the reason is that there is no reason. But I think sometimes it's easier just to use the same formula that you're familiar with, and I'm talking about this one right here that I'm putting a green star next to. We're all very familiar with that formula. We've been using it for the entire unit. So it's easier sometimes just to figure out the amplitude and then multiply it by 2, even though it kind of was some unnecessary work. So now the last thing it asks is, which one has the greatest diameter? And the answer is the one that's the largest, which again is Skywheel. So this one has the greatest diameter.